Now, on this video, we'll be talking about lightning. Most of us will call it thunder. The lightning is the one we see. That is the light you see. That's the lightning. Then the sound is called the thunder. Now, this event happens at the same time, but as we all know that speed of light is very, very high. So speed of light, very, very high. So we get to see the light before the sound. Why? Because of the speed at which the light travels. The light travels faster. But this event happened at the same time. So when this lightning struck, it released up to 11 kV. That's 11,000 volts. And these voltages, they keep traveling until they meet a high resistive path. They can travel to your roof, can damage your roof. If they hit your roof, it can result to fire. If they hit lightning arrestor, there's what we put on our roof. We call it lightning arrestor. Once it hits the lightning arrestor, the heavy voltage will be traveled towards to ground. It will be dumped to earth, into the earth. So you have to use thicker cables when it comes for your lightning arrestor, because the voltage that is coming is very, very high, and it needs a suitable path that will not fail to send it to ground. And your earthing must be very, very firm to be able to dump that amount of current. If not, it can result to fire outbreak as well. So, as I said from the beginning, that the voltages that is being produced from lightning will travel until they meet a high resistive path. If they travel on grid, that is on your normal NEPA line, our normal NEPA light that we have in Nigeria, that we call it NEPA. If they travel on that NEPA line, it will keep traveling until it gets to a high resistive path. If you go back to the transformer, it can be dumped to the transformer earthing. It can be absorbed by the high tension, because they have earthing also that pull any excesses from the line. But if it travels to your house, can destroy your TV, can destroy your electronics. It can equally destroy your inverter if you have an inverter in that house. That is why some installer will tell you that when rain is falling, switch off your grid. That is the grid breaker, Then you switch it off, because they know that with all the amount of protection, if lightning ventures come close to your system, it might destroy the inverter. And it can equally fall on your solar panels. The lightning can equally fall on your solar panels. And this heavy voltage, this heavy pressure can travel to your charge controllers and equally destroy your charge controller. But if you have SPD, that is surge protective devices, they will create a path at which this heavy voltage will travel to ground. So if you have any SPD and it's not connected to earth, you just install a symbol, not a lightning protective device. So the earthing is very, very important, because it creates a path for lightning pressure to go to ground. So if rain is falling, you can as well switch off your PV breaker. Your PV breaker is the solar panel breaker. So once you switch it off, any excesses, any voltage, any current that is coming will not even get to your inverter. So with that, you will be safe. Now, there's one thing I must tell you. You have installed your SPD, you have installed your lightning arrestor. It still depends on the quality of the installation. If not, the lightning can equally imagine you use 1.5 or 2.5 for your earthing. That heavy voltage can melt the 1.5 and still pass and destroy your system. So advisably, if there's somebody at home and you see rain wants to fall, you can use your lights in your house, but switch off the grid, switch off the PV breaker. So the energy that is coming from the grid cannot access your house. Energy that's coming from the roof, that is from your PV, cannot equally access your house. But this lightning, as we all know, is an atmospheric discharge when the atmosphere discharges it itself and this heavy voltage begins to travel to our systems. So good earthing system, you have to use standard. Use your earth bar, your earth mat to create a suitable path for lightning that that will occur or that will eventually occur, because it will happen. It will happen. So we'll make more videos on how to connect your SPDs and how to protect your system from lightning. But just bear it in mind that lightning releases or discharges heavy amount of voltage, amount of pressure, and this pressure can only be granted. This pressure can only come in contact with a high resistive part. That is when it can now be converted to what? To heat, and this heat can now dissipate to the environment. So I hope you enjoy this lecture. So you can drop your questions at the comment section for more videos. Thank you.